Hey, what's up? It's your old pal, Mr. Cook. And you know what? We're going to be working on this test review. Looks like we got through the first 11 problems and we're on the last page. So let's do, well, I don't know. Let's see how many problems we can get through. Start this up. Let's see, number 11. So it says that y is equal to e to the x squared. And then what this notation here says is that it's looking for the second derivative. So y double prime. That's what we're looking for. So we have to find the first derivative first, then we take the derivative of that to get to the second derivative. So let's do it. So y prime. Well, it looks like we've got a chain rule problem because we've got a function on the outside, the exponential function, and then a function on the inside, x squared. So we just, do the derivative of the outside part first. What's the derivative of e to the something? It's just e to the something, right? So it's just going to be e to the whatever. But then we need to multiply this is the chain rule part by the derivative of the inside function. And the inside function is x squared. The derivative of x squared is 2x. Okay, there's our first derivative. And since I have to do the second derivative, I would think to, simplify this a little bit. But there's not a whole lot to simplify, honestly. It just is two functions. It's this guy here and this guy. So I've got to find the second derivative. And the derivative of two functions multiplying can be found by using product rule. So I'm going to use the product rule now. So these take turns, with their derivatives. We take the derivative of the first function, e to the x squared, and we just found that. It's, I can just literally list it off. Just the problem that I had before. E to the x squared times 2x, that's the derivative. And then I need to multiply that by the other function, 2x. And then to that, I'm going to add on the derivative of the other function, and that's going to be 2x. So 2 times the other function, untouched, so e to the power of x squared. And there's my second derivative. I'm tempted, oh man, I'm so tempted to simplify this, but nah, you know what, I got other stuff to do. I'm kind of busy, so I'm just going to leave it like that. I'll let some other person simplify it for me. Okay, number 11 is done now. Let's take a look at the next couple. The next one says to find the equation of the tangent line. I know that. The equation of the tangent line, that's the same thing as number like whatever, 10 I think it was or something, right? Yeah, where I just used the point slope form for this one. This is very familiar to me. So y minus y1 equals m times parentheses x minus x1. And I already told you that you usually have a coordinate. And look at that. It's right there. That's going to be our x1 and our y1. So let's plug those numbers in. 1 goes in for y1. 1 goes in for x1. And all we need to do is find m. And m is the derivative of this. Derivative of this. Oh, look at that. I've got a function that has y's and x's in it. I've got to use implicit differentiation for this. So let's do that. All right. We take the derivative of y to the fourth. That gives us 4y to the third. And then whenever we take the derivative of a y, we've got to do a dy dx on it. Plus, and then we've got an x and a y. I treat those as separate functions. So this is going to be product rule. So I take the derivative of x first. The derivative of x is just regular old 1. So 1 times y plus. And then I take the derivative of the other thing. The derivative of y is dy dx, 1 dy dx to be specific. And then I multiply that by the other function on their x. Okay, let's do the second half, the right-hand side of the equation. The derivative of x to the third is 3x squared. The derivative of negative x is a negative 1. And the derivative of a constant is just 0. So my next goal is to get dy dx all by itself. So I take all the stuff that doesn't have a dy dx on it, like this stuff here, at 1y, and I move it to the other side. So I've got 4y to the third dy dx, and then plus, and let me rearrange that a little bit. It's the same as saying x dy dx. If I just, swap the multiplication of these two things, that's no big deal. That's the commutative property of multiplication. We're allowed to do that. And then I'm going to move that 1y over the other side because it does not have a dy dx multiplied on it. So that gives me a negative y, and then a positive 3x to the second power, and a negative 1. Okay, since I've got multiple dy dx's, you can think of them as like numbers that are multiplying. What I would want to do if I have common numbers is factor them out. So on the left-hand side, notice that this term and this term both have dy dx's. I would factor those out, so dy dx on the outside. And then on the inside, if I take out the dy dx from the first term, I just have a 4y to the third. And if I take out a dy dx from that x dy dx, I just have a regular old x. And then it's equal to the other stuff. All right, Now to get dy dx all by itself, it's multiplying by all that stuff right now. I would just divide it out. Okay, so I'm just going to divide by all that stuff. 4y to the third plus x. And now I've got my dy dx all by itself. And that's what I wanted in the first place, the derivative. All right, so there's my derivative. But that's not all, because from the derivative, I need the slope. And to get the slope, I need x's and y's, and that's going to be where I use my equation, okay? So the derivative at this point, so dy dx, when x is equal to 1 and y is equal to 1, is going to be the following, okay? So I just write it up in the following way. I plug in 1 for y, plug in 1 for x in the equation. So negative 1 minus 3 times 1 squared minus 1 all over 4 times 1 to the third plus 1. You know what I could do in this case? I mean, I could spend some time figuring out what all that stuff is, or I don't know if you're going to like this or not, but I mean, I can do it. I can just plug all that stuff in for my slope. This is maybe taking not wanting to simplify to an extreme, I guess, but I don't really care. I'm going to put all that stuff up here. So let's see, I've got negative 1, just to prove a point, minus 3 to the first, times 1 to the second, and then minus 1 all over 4 times 1 squared, or is that squared or third power? Third power, sorry, third, and then plus 1. Okay, so I just got to make sure all my stuff is correct. Yeah, we're good. All right, there you go. I don't really care what that number is. Whatever it is my slope, and I put that in the equation. So here is my tangent line that I wanted. And it's right, because I don't really care what this is. I don't know. You can take a couple seconds to figure it out probably, but I want to be as lazy as possible, I think. All right. So next up, I think, let's see, we did 11, 12. Let's do one more. Let's do that number 13. That looks kind of fun. And then I think we'll do the last video, 14, 15, 16, 17. Yeah, we'll do it in that order. Okay, here we go. So now we got to do the derivative for this function. And I guess this would be the only tricky part, e to the x minus y. It is chain rule. And also you can't separate the x's and the y's. So this is going to be implicit differentiation. But here's what's neat about it. The exponential function, it doesn't matter how it derives. You're going to get the derivation, the dx, the dy's, the dx, dy's, or dy dx's, from this part. So you just treat this like a chain rule, okay? With an exponential function like you usually would. E to some function, the derivative of e to some function is e to some function. So this part, this derivative, is e to the x minus y. But then, from the chain rule, now you need to multiply by the derivative of the inside function. And this is where you get to use your, dy dx's and stuff like that, okay? So the derivative of the x part is just a 1. The derivative of the y part is dy dx. So that's the derivative of the first part, okay? All right, next up, we got to take the derivative of 2x squared and also negative y squared. So derivative of 2x squared is going to be a 4x to the first power. The derivative of y squared is 2y. And my goal is to get the derivative, right? So I need to put on, since I did the derivative of y, dy dx on that one, okay? I got to get the dy dx's all by themselves, but this might create a little bit of confusion. So I'm going to kind of elaborate on that a little bit. What you want to do is get dy dx by itself. In its current state, the dy dx is kind of stuck in these parentheses. So try to use distributive property to free it up, okay? So we're going to multiply e to the x minus y into both of those parts. E to the x minus y times 1 is just e to the x minus y. That's part of the distributive property. And then the other part is distributing it into that negative dy dx. So I also get an e to the x minus y attached to the dy dx. There we go. Now that has freed it up a little bit, and it's going to allow us to get dy dx all by itself. All right, let's put the dy dx stuff on one side, the non-dy dx stuff on the other. So maybe I'll move this part over here, to pair with the other dy dx, and then I'll move the 4x over onto that side. So here's how it would end up looking so far. E to the x minus y is equal, e to the x minus y and then minus 4x is equal to, and then I move the other part over there, so I get e to the x minus y and then dy dx minus 2y dy dx. Okay, and then we follow the same rules that we have for implicit differentiation. So we factor out the dy dx from both of these terms. And then we divide both sides by, like, this stuff, because it's multiplying on the dy dx. And we want the dy dx all by itself. So now we divide it out. So dy dx is equal to e to the, I've already forgotten what it looks like. Oh, whatever, I'll just kind of guess it. X minus y and then minus 4x over, I think it's e to the x minus y minus 2y. I think that's right. Equals that. Or whatever it was. Well, I guess I could check real quick. Yeah, that part stays here. That part moves over, so it'd be negative. This part becomes positive. That one stays negative. Yeah, that should be right. Okay, there you go. So there's number 14. I'm going to put a little box around it. I'm pretty confident that this thing's right. And I don't want to simplify it. I just want to leave it on its own. Okay, so that's all the way through number 13. Do we want to do 14 real quick? Do we got time? Yeah, let's do number 14, whatever. It's the same thing, right? Implicit differentiation. And we only have to find one derivative, unlike the next one. So yeah, let's do it. Why not? All right, so derivative of y, that's dy dx. And then derivative of this one, this is going to be product rule. So we're going to do, now this is actually an important thing to mention, okay? See how I have like a negative sign on there somewhere, right? This is the same as saying like plus negative 1 times x squared times y squared. That negative 1 is either going to be attached to the x squared or the y squared. What I like to do is just like lump it together with one of them, so it's not like floating around. The negative 1 isn't on both the x squared and the y squared. It's on one of them. So just like pick, if you have constants, just attach it to one of the functions. That's what I'm trying to say. So I'm going to attach it onto that x squared, okay? So when I do my product rule, here's how it's going to go. So, this is dy dx, right there. And then minus, or, well, let's say plus, and then the derivative of the first function, negative 1 x to the second power. Well, the derivative of that is going to be a negative 2 x to the first power times y squared plus, and then I do the derivative of the other function, 2y dy dx, and then times that negative 1 x squared. And then that's equal to the derivative of some constant, which is just going to be 0. Okay, there we go. Now I can make this look a little bit nicer. And I think I might break from tradition a little bit. And instead of having the plus minuses, I'll just have some negatives. So I'll just rewrite it real quick. dy dx, and then minus 2xy squared. And then let me move the x squared out to the front too. So minus 2x squared y dy dx equals 0. Let me make that look like an x instead of an alpha. I don't want to confuse myself later. Okay, now to get dy dx all by itself, I move all the non-dy dx terms over to the other side. There's only one of them. So here's what I have so far, dy dx, and then minus 2x squared y dy dx is equal to 2xy squared. All right, now I want to factor out the dy dx part of it, so take that out, dy dx. And if I divide out a dy dx from this, I just get 1, okay? And then if I take out the dy dx from here, I get 2x squared times y, and that's equal to 2xy squared. And then I just want to get dy dx by itself. So if I'm multiplying by this stuff, I just divide, and I get my answer. Dy dx is equal to 2xy squared over 1 minus 2x squared times y. And that's my derivative. All right. Now I got to do 15, 16, 17. You know what? Let's do that on the next video. I think that's enough for this one. All righty then. That's the end of this one. I hope you enjoyed it. I hope you got something out of it. And I hope to see you on the next one. All right. Toodaloo. Bye-bye.